Yeah, 10 minutes to your presentation. You can utilize this time to settle down just in case you want to have a few checks. We can't hear you. Let's go. You'll have to just raise the volume. Not yet. Now you are unmuted.
Okay.
Yay. Now I hear you.
Now I can't hear you.
You can't hear me? Can you hear me now?
Can you hear me?
Yes, I can hear you.
You can, but I can't hear you.
Oh. Can you hear me now?
Are you able to hear me now?
Yes, Mr. Gu, I can hear you now. Though your camera is off, so I can't see you, but I can certainly hear you. Can you hear me? Yeah. No. No. Since your camera is on, I can just probably understand what you're trying to ask me, but I can't hear you.
Testing.
Oh, I can
now?
hear you now.
That's good.
I'm glad. So I'm really glad about you making it 10 minutes earlier.
Yes, definitely. Doing some checks first, right?
Yes, sir.
How do I address you?
Okay, you want to just check about how you can share your screen before we begin to address to our attendees?
Sure.
Yeah, you can give that a check.
Okay, how is this? Are you able to see my screen?
Not yet.
Okay, hold on.
I think you need to use that share button.
It's okay.
Correct. And go to your presentation. Perfect. We can see it clearly now.
Sorry. Let me
No,
just
that's
close some
fine.
of the screens.
So now it's perfect. Okay.
Okay.
So you
That's
can
good.
keep it ready. And
Yeah.
I think like we have a fair number of people for me to get going with at least a little introduction to you so that you get that little extra time just in case.
Okay, sure.
Is that okay with you?
Yeah, that's okay. I'm fine with
Okay.
it.
So we can get going.
Yes.
All right, then. For all the wonderful people out there, our attendees making the best of Automation Expo Connect, let's tell you we have with us Mr. Roger. He has been in the ICT industry for more than 20 years now and has achieved several ICT certifications in structured cabling, test and measurement, project management, network and operating systems, data center and intelligent infrastructure management. He is currently responsible for Fluke Networks APAC technical support. Was I right with those facts?
Yes, you can say Asia Pacific instead of APAC.
Okay, I love that correction. All right, so all yours, Mr. Koo. Please go ahead. We have a good amount of 28 people here waiting to listen to what you have to say. And trust
Right.
me, we look forward to they being potential attendees. All the best.
Thank you. And good day, everybody. Good morning. Well,
Good morning to you too.
the goal of today's topic is actually to understand the importance of cable testing in your industrial automation system. Through this presentation, we hope you can gain valuable information to increase your productivity. If you have experienced frustrating intermittent system or connectivity issues, which took away precious time and resources to find the cause, then this is one of the presentation for you. Let's start with a look at the trends in industrial automation installations. According to a recent market survey, 65% of new IA installations employ some form of industrial Ethernet and is growing rapidly. Look at the green portion. Within this group, Modbus TCP was one of the first industrial Ethernet introduced, but Profinet and Ethernet/IP are the most popular ones. Few bus technologies are still showing a decline over the previous years, but the decline is stabilizing. In Asia Pacific, Profinet and Ethernet/IP are still the most popular technologies being installed, followed by Profibus deployment, but the market is still fragmented. Interestingly, the wireless portion is gaining momentum as a deployed automation technology. Now, in another report on the adoption of industrial Ethernet, while despite the COVID-19 crisis, IE is estimated at US 35.4 billion in 2020 and projected to reach 97.8 billion by 2027, growing at a compounded rate of 15.6% over this period. What a tremendous growth. So what is the adoption of IE increasing so rapidly? IE is seen as a universal solution across the whole manufacturing operational environment. No longer are the production and office networks seen as separate operations. Ethernet, first officially published by IEEE 802.3 in 1983, has been around for more than 40 years. Compared to other protocols, Ethernet is more deterministic, supports higher bandwidth, and is simple to maintain, all attributes that industrial Ethernet requires. The backbone where Ethernet runs on is the cabling infrastructure. Understanding how to maintain and care for the physical layer is of vital importance to the overall productivity of the operation network. According to different sources, over 50% of IE problems come from the physical layer. Cables and connectors form this layer, and this can be pre- or field terminated. Pre-terminated cables are designed and configured beforehand. manufacturer tested, and delivered to the site for installation. Issues could arise from wrong cable for the application, re-termination at the site as the slack could be too long, or damaged cables during transit. Few terminated cables, in addition to the issues mentioned above, could also be subjected to wrong wiring, untwisting too far into the cable, resulting in higher noises or loss of shielding integrity. Industrial environment demands higher level of design and workmanship quality as the environment makes everything worse. From an architecture perspective, operational technology, OT in short, is a lot like information technology, IT. Both have end devices that communicate through a fabric of switches and gateways. OT in industrial automation is a category of computing and communication systems to manage, monitor, and control industrial operations with a focus on the physical devices like PLCs and VFD. In short, it basically interacts between machines. IT deals with mainly computers and telecommunications, like you and I know, for performing various input-output operations for storage, transmissions, manipulations, reporting. Basically, it's a conversion of data to information so that it can be exchanged among different parties. It deals with information rather than machines. While must have heard of IT and OT conversions, and sharing the same physical layer is a major step in that direction. In the IT world, Ethernet has grown to become the world's most common networking system. In OT, vendors and standards organizations have adopted the underlying physical layer of Ethernet to create a variety of technologies such as Ethernet/IP, Profinet, EtherCAT, CC-Link IE, Modbus TCP, just to name a few. All these protocols are optimized for industrial automation, sharing the same physical layer. The same cable types, Cat5e, Cat6, Cat6a, albeit with additional jacketing to protect from the harsh environment. The same connector type, like RJ45, which are often industrialized. There could be specialized connectors like the M8 or the M12 that you see here. Some fibers may also be involved, again, with added protection on the outer layer. Now, Fluke Networks products works on the physical layer for both the OT and the IT. Like the IT network, testing the installed for industrial network is necessary, more often required. Changes in production line, movement of resources and machineries, new switches, routers, PLCs. When we are planning out the new industrial Ethernet network, we tend to ignore the cabling, assuming everything will work out fine. We forget that unless our cabling infrastructure is good, these technologies and applications will not work correctly. The data cabling is the foundation of our network. If you do not get it right, you do not test it out correctly, you could be headed for serious issues that can be hard to correct once the network is in service. All stakeholders involved need to ensure operations are not disrupted and project running costs are maintained at an acceptable level. Without proper testing, you may face with longer startup time. Things may not work right off after assembly, and time will be wasted getting it to run due to a cabling issue. Move, adds, and changes are typical in a production line, and any of these activities prior to verifying the cabling will cause the whole line to go down. Not forgetting moisture, vibration, contamination, EMI, any of the outages can cause more than testing correctly in the first place. Here's an example of a utility vehicle manufacturer in the US that we have worked with. Every hour of production, they are able to produce 6 trucks, and that amounts to about $240,000 per hour. If production is down, typically they will suspect it's the cable issue as the first step, and they will install a bypass cable. Or instantly, a bypass cable will require them an hour to install. After checking the cable is working right, then they will move on to the next device to check the status. Now, if they do have a cable tester, installing a bypass cable and doing a test on this cable takes only about 10 minutes. That's a saving of about 50 minutes, which is equivalent to $200,000. This manufacturer himself, I'm happy to report that it has saved them at least this amount because a testing itself pays for itself in a few minutes. If you are producing milk or a beer, now imagine what kind of savings you will have in a production environment. Standards organizations recognize the need to address the harsh environment that can cause intermittent network problems by creating the TIA 1100-05-A standard as well as the ISO 1100-801-3 standard. They both refer to MICE, where M stands for mechanical, which deals with vibration and shock, I for ingress, which is water and dust, C for climatic or chemical, as temperature and humidity, and number 4, electromagnetic for EMIs. Each of these attributes are assigned a rating to indicate the severity of the environmental conditions, 1 for low and 3 for high. My standards apply to cabling products supporting all industrial Ethernet protocols. So when do you test the cables then? Well, Fluke Networks tools can be used to validate and verify industrial Ethernet cables to avoid startup delays. During assembly, cables can be checked if they are terminated properly with the correct configuration, shielding, and conformance to MICE ratings. During installation, verify the cables are not strained or broken. Validate the signal loss of the link are within acceptable limits. So where should validation and verification take place? Well, at the machine builder or the OEM. But the purpose is to catch the problem before the machine was disassembled and shipped to customers. Test again at the destination plant when delivered and reassembled to ensure nothing is broken or changed. Lastly, to always remember to document all cable test results with complete details of all measurements for verification and traceability. So what can you do if the cables fail then? Due to handling and various environmental factors, cables do fail over time. What is important is to be able to minimize the downtime, identify the cause in the shortest possible way, and rectify it. A complete cable test, end to end, take less than a minute. If it is good, great. You have eradicated the physical layer as a possible cause. Move on to find for other possible fault sources. If it is bad, you know what to do. So what will we test? Let's take a look at this typical link that includes both the endpoints. Here is a picture of a 4-paired cable. At the ends of these cables, they are connected by an RJ45 plug and inserted into a jack. These connectors, besides RJ45, it could also be M8 or the M12D, which are 2 pairs. And this is a M12X, which is a 4-pair cable or connector. There's an additional administration point for the patching if needed. Also, optionally, there could be a zone enclosure where the media converters are situated. So in this picture, this is an adapter that converts M12 to an RJ45 connector. Now, miswiring is the biggest source of issues in data cabling. The simplest of problems can lead to large issues in an IE network. You can see from the diagram to the right that we have placed our terminator at the far end, which is right here. It is terminating the M12 exit connector at that end. Our industrial Ethernet kits provide the terminator and the appropriate test interface cables, as you can see from the bottom here. Link IQ is connected to the link at the near end using an RJ45 to M12 Xcode patch cords. We have a full set of adapter cables available to facilitate the testing of commonly used industrial Ethernet connectors. Now let's take a look at the test result. Let me just zoom in so that you can take a look at it. It is very clear that the tester is showing that pin 1 and 2 are shorted together at a distance of about 4.5 meters away from the tester. Now this indicates that the wiring is bad. Here we have a perfect link. Everything is working fine. And the link can support a transmission rate of up to 10 gigabits per second. In the previous slide, we could have saved those test results to the tester to document what we have found. Thereafter, we can upload them into a Linkware PC software, which is a free product from Fluke Networks, and print out the testing report to show that the cable and switch ports were working correctly. Here's another example of a case shared by one of our customers. This is a wind farm located at the edge of the California desert. There was a PLC that's reporting network fault code, and despite several interventions from the field technicians, they were not able to identify the fault where the machines shut down intermittently, causing a loss of productivity. So with the testers, they are able to identify that the wiring is actually not correct. Although the endpoints are correct, that's pin 1 to pin 1, 2 to 2, 3 to 3, but the wiring within the twisted pairs are incorrect, resulting in what we call a split pair wiring. While the field technicians has been using a continuity tester, and a simple continuity tester will not be able to detect this issue. With the Link IQ, we can also perform connectivity and PoE checks. In this model, we connected the Link IQ to the switch port or to the link termination as shown. This will enable the evaluation of the switch port, VLAN identification, and the PoE capabilities. We tap Auto Test, and like the cable testing, the Link IQ will determine what it is connected to. Once the test is completed, we can review the results on the Link IQ. Here, we can see that this switch are connected to port 1/0. Let me just zoom it out. Port 1/0/3 interface. It is connected to a switch called the switchy max switchy and to a VLAN that is named access LAN. It has the capability of connecting to a 1 gig Ethernet, but it can also support 110 megabits per second at full or half duplex. This switch is capable of offering power on all 4 pairs. With hardware negotiation, the switch is capable of offering up to class 4 PoE power, which is 25.5 watts. Again, let me just zoom it in so that you can see it clearer. Under software negotiation, the switch is capable of offering a little more power, class 5, which is 30 watts. This tells us that most likely this switch is a newer IEEE 802.3 PoE capable switch. Showing the advertised power level by the switch is insufficient. Link IQ applied the appropriate load testing to verify that the switch could deliver the power levels it is advertising. The switch may be capable of even more power, but at this point in time, it only has reserved to supply up to 30 watts PoE from this port. All the tests that we carry out at the switch port can also be conducted at the other end of the link. This enables you to eliminate the cabling as a source of connectivity or PoE issues. Now, if you'd like to find out more, Fluke Networks has a dedicated website on Industrial Ethernet. So do remember to subscribe with us to stay up to date. In the website, you will see information on Industrial Ethernet cabling standards, how cabling tests can be conducted. There are white papers, videos, knowledge base articles, and configuration information as well. Tech support is also available around the clock for Go support customers. Now to conclude, the cabling used in the industrial plant is the foundation of your control network. Remember to build a robust foundation because applications run on it. Make sure you test, validate, or certify the cabling correctly. And do remember, just wire mapping testing is not enough. Over 50% of all industrial network issues are related to cabling. So as a rule of thumb, if there is an issue, eradicate the physical layer first. Seek advice if you are unsure. There are many suppliers and vendors out there that have great guides for their products. Fluke Networks are considered the world leaders in cable testing, and we can definitely help. That's all that I can deliver for today. And if you have any questions, you are free to visit our virtual booth where we can answer you. And at this point in time, I'd like to open up for questions.
Thank you so much, Mr. Koo. So I'm sure even if we don't have questions coming up on this window, you will certainly receive some email or you have people visiting your stall virtually. Thank you for sharing with us so much of information based on the importance of cabling.
Oh, thank you. Thank you very much.
Well, I must say that was an amazing presentation put together.
Well, if anyone is interested, we do have a another session in half an hour, which will give you more details on what the tester will do. So,
Okay, that's nice.
yeah,
So please share that with us on the chat box, just in case we have our attendees wanting to get the details. So you
sure.
can feel free to put that on the chat box.
Yeah, definitely we can do that.
We have Mr. Anand Kumar from the attendees who has complimented you about giving a nice presentation and thanked you.
Oh, thank you. Thank you, Mr. Kumar.
So if you click on the chat button below your screen, you can certainly view that. And at the same time, that's where you can type in the info with regards to your next session.
Yeah, I think I'm having some issues on my machine.
No, but I think that you shared your email ID. It's certainly going to help
Yeah.
people. Thank you for utilizing the time correctly and finishing beyond time, respecting the others coming up next. Since we don't see too many questions, let's take a leave from here. Thank you once again, Mr. Roger Koo, and we wish you all the very best while you're around at Automation Expo Connect.
Well, thank you. Thank you everyone for your time. Before I leave, I would like to wish all of you safe and healthy for the rest of the week. Thank you.
It's very kind of you, sir. We wish you the same. Thank you.
Thank you. Bye.
All right, friends. Then that was Mr. Roger Koo giving us the importance of cable testing in industrial automation systems. We have our next presentation based on new product introduction with e-factory solution coming from Mitsubishi Electric India Private Limited. This session will start off at 11 a.m. We'll wait for our speakers to be here and we'll take it from there. Till then, utilize this time to go into the various halls that we have right here on this virtual platform of Automation Expo Connect. We've got 4 halls, we've got 100 plus exhibitors, and more that you can even think of. We're very proud to say that being at platform like this and trying our hands at this for the first time, we've been indeed very successful. And I think that what you get in return when we do 14 complete editions of an automation expo. Yes, technical glitches is what keeps happening, and the challenges that we are facing, trust me, I think to some extent, the team behind there is really enjoying dealing with it and coming out with the best. So go ahead. I'm not taking more of your time. Go ahead right there and enjoy Automation Expo Connect.